Hello, my partner's name is Maciek and my name is Sander, and together we did the assignment 1 for computer applications. First of all, in the assignment, we got a EQ and an SSH file, and we need to parse information and connect it to an SQL database. After we parsed all the information, uh, after we parsed all the elements separately, we could make a bus branch. And after the bus branch, we could also determine the Y-bus metrics, which was the main task. As an extra, we also did a graphical interface. So first of all, the SQL databases. So we got the big file, EQ file, and also the SSH file. We parsed the information for every node separately. You see here that we have base voltage for terminal connectivity nodes, etc. I will go a little bit deeper into the base voltage. We saw that every node has something in common, which is an attributes, elements, and child nodes. That's why, to make it generic, for all those three, we made separately an array. So here the attributes array, elements array, and child nodes array. We asked here the information that was needed or was required in the table in the beginning of the assignment. After making these three arrays, we used a method which we created, which I'll explain next to this, extract information, to make an array of results, which is shown here by base voltage. Now I will go to this method, extract information. Here. So here's the extract information, the method we created. We also used the get elements by tag name, which we also did in the exercise. And we looped through all the attributes, all the elements, and also all the child nodes until we got all the information. So back to the SQL database. So that's how we parsed all the information which was necessary from both files. This was the first part, and now we want to connect it to the SQL database. I'll go a little bit faster. Here, first of all, here is the connection made, and we have our own username and passwords. So we see that first we need to register, we open the connection, and then after the statement we could create tables, inserting all the records and all the information which we just had parsed. I will show one example of how we made a table, because we did it again for all the elements, but we used the SQL language, and we saw that which if it is an ID, we need to have a varchar, which is the same as a string in Java, for example, and a float is for a number. Then we created all the tables and inserting all the records. So this is how we did it. And now I think we can already show you. First, here is the SQL database. We see that it's empty, still empty, except for the login. We assumed that the database was already created, because otherwise we could not store our login for the users. And with this password we could use at the GUI later on. And now I will show you that it worked by running the file. Here we see that it works, and the end result, if I refresh it, is here, for example, generating unit. We see that we have got the name, the maximum power and the minimum power, and the equipment container ID, but also for example the ratio, tab changer, we see the name and the step voltage, which was necessary to later on build the bus branch. So this was my part, and now Maciek will continue with the main file.
So in the main file, we basically repeat a couple of stuff from the SQL database file. So we again parse the document, we extract information using this method, and we also have a lot of classes here, as you can see. Each class represents kind of physical or non-physical equipment in the system. So, for instance, if you go to perhaps let's go to base voltage, for instance. So in this class we have a constructor and ID, nominal voltage, and name. We also have a method, insert table SQL. So we use this later to insert values into the SQL cells. And we override the toString method to print out stuff. And we do this for every other of them. For instance, power system. Maybe this is actually a better example, but ratio tab changer. So we repeat the same structure for every class, and then in the main file we create objects in each of those classes using our parsing that my friend has already explained. And we repeat this a couple of times. For a couple of classes we need much more information that it was required from us to parse and store into the database. So we need some, for instance, terminals, or we need base voltages for all of them, or the voltage levels. So we also save them in the objects. For instance, for the breaker, you can see that this class is much complex because we have name, equipment container, the base voltage ID, then the base voltage value here, the state, terminals, connectivity node, and so on. So this is much more complex. And we repeat those processes a couple of times, and then in the end we have all of them stored as objects in our classes, and we create two new array lists: physical equipment list and LGS list. This stands for load, generator, and shunt. And we start adding breakers, energy consumers, machines, power transformers, and so on to appropriate lists. So to physical equipment, and load, generators, and shunt to LGS list. This is super useful for us later because we determine our buses, because we have like 9 buses, but actually only 5 or 6 of them are real buses. So we want to determine which of them are the real buses. So we are looping through the LGS list, and we see if any of them is connected to this bus, if the equipment there is connected to the bus, that means it's a real bus. If not, then we disregard this bus. And then we create two important arrays. One of them is bus equipment. Second one is branch equipment, and we have described them in this Word document. So for the bus array list, we have bus sections, and we store the bus number, RDF ID, connectivity node, and a lot of equipment that is connected to this bus. So from 1 to till n. And then in the branch table, we store branches that belong to different bus bars. So we store the equipment that is connected to the branch, and we also store from which bus this branch goes from and to which bus it goes to. So for instance, to bus bar section 1, we have always from bus is always 1, but 2 bus can differ depending on how many branches we have and to which bus bar section they're connected to. And so we do this here, and the branch array looks much more complex. And we also have a small method for breakers. We want to determine the breaker state. So if the breakers is open, then we need to delete the branch, of course. It's done in this small for loop. For this example, all the breakers were closed, so all of them are found as closed, so no branch is deleted. And then and here we are doing our Y-bus matrix. We have 2 methods, diagonal and non-diagonal, to fill our diagonal and non-diagonal elements. We have the methods described here, and we start looping through the branch equipment, and depending on several conditions, we are inserting them into appropriate diagonal or non-diagonal cells. And then in the end, we create the table for the Y-bus, and of course we also want to save the table in the database as our Y-bus table. So I'm gonna just run the program now and show it works fine. Let's run it. Yeah. So you can see our Y matrix here. You can take a look at that, and let's also here we print out all of stuff that was used for the debugging, but also to show how it worked. So yeah, the program is in different buses and different bus bars, and then it defines physical equipment elements that are connected to the bus bar, then it creates branches, it iterates through all those elements, and it adds them. Like usually it's like 3 of them. It's a breaker, then maybe a transformer, and another breaker, and then it closes the branch. Then he also finds out the breakers, if they're closed over. Here he found 2 breakers that were both closed, and same here, and yeah, and so on. If there was an open breaker, then it would just delete the array, the branch, sorry. And yeah, so we also printed out what's like. We have the branches here from bus 0 to bus 4. There's a transformer, AC lines, transformers again. Yeah, this is basically done for all the branches. Then we get to the database, we create the Y-bus, and yeah, we store the Y-bus in the database. And now my friend will also explain a little bit about the GUI. Before that, I also want to show you that yeah, we have the Y-bus in our SQL database here. Yeah. Exactly. So it's also stored here. Now my friend will conclude. Yeah.
Alright, so we managed to get a Y-bus matrix from the EQ and SSH file. And lastly, we also made a small graphical interface, which we made here in Java. I think I can just show it by running it. Here we have. So if somebody else wants to enter this our database, it will give an error.
Yeah, because we have predefined the users that will have access to our Y-bus matrix. That's why we had to have the database created already before running the program.
Exactly. So now we show it with correct. Now it's correct, and we go in. And lastly, we want to see our Y-bus matrix, and it is visible over there. And I think this is it, and we managed to do the assignment 1, and I hope you like our video.
Yeah. Thank you very much.
Yes, thank you.